Children, now let us continue the chapter electricity. Now let us continue the exercise based question of the chapter. The seventh question. The value of current I flowing in a given resistor for the corresponding values of potential difference V across the resistor are given below. Plot a graph between V and I and calculate the resistance. Now let us draw the graph here. Here voltage is taken on the x-axis and current is taken on the y-axis. Voltage is taken on the x-axis and current is taken on the y-axis. And here let us take the first. Current is 0.5 and volt is 1.6. Current is 0.5 and V is 1.6. So here volt is taken on the x-axis, that is 1.6. Approximately this is 1.5. So let us take little more, that is 1.6. Let us take here and go straight. The current is 0.5. So that is in between 0 and 1. The point may be here. So you will get, that is the point 1.6 which is on the x-axis and 0.5. 1.6, 0.5. 1 point you got here. Next, volt is 3.4 and 1.0. Here the question is plot a graph between V and I. So we have taken V on x-axis. So let us consider the first value for V, that is 3.4. 3.4 means this is the middle of 3 and 4, which is 3.5, and little less you take here. And current is 1. Current is 1 means straight go to this here. So you will get the point, that is 3.4 and 1.0. Next you go the third one, 6.7 and 2.0. 6.7 and 2.0. 6.7 means this is 6.5, more than 6.5, so approximately it comes here. We go straight to reach to here, then here is 2, so you can have the point here, that is what, 6.7 and 2. Then the next one is 10.73. 10.7, 10 is here, and the middle of 10 and 11 is 10.5, so little more than 10.5, and go straight to 3. Here to get the point. So approximately you will get the point here, that is 10.2 and 3.0. The next last one is 13.2 and 4. 13.2 and 4. Here 13.2 means little more than 13. So we go straight to get 4. So approximately you will get here, that is 13.24. Now let us join all these points. 1, 2, 3, 4, 5. Now we got a straight line for the graph between V and I. Here we have to find the resistance of the resistor. To get the resistance of the resistor, you write the formula R equals, you know that, V by I. That is nothing but V2 minus V1 by I2 minus I1. V2 you can take here. V2, here you take any V2, or you take any two values here. So let us take 6.7, 3.4, 6.7, 3.4, or you can also take 3.4 and 1.6. Any two consecutive take, or first and last also you can take here. Here you take V2 is 6.7 minus 3.4 and corresponding I2 and I1, that is 2.0 minus 1.0. 6.7 minus 3.4 is 3.3. 3.3, that divided by 2 minus 1 is 1.0. Then you get 33 by 10. So equals 3.3. 3.3 ohm. So the resistance of a resistor is 3.3 ohm. Now the question number 8. When a 12 volt battery is connected across an unknown resistor, there is a current of 2.5 milliampere in the circuit. Find the value of the resistance of the resistor. Here the voltage of the battery is given, that is 12 volt, and also the current in the circuit is given, that is 2.5 milliampere. We have to find the resistance of the resistor. Now you write given, write solution. What is given here? V equals 12 volt and I equals 2.5 mA, that is milliampere. So you express in terms of amps, that is 2.5 divided by 1000 amps, that equals 2.5 into 10 to the power of minus 3, because it is nothing but 2.5 by 10 to the power of 3, 10 to the power of 3. So it is 2.5 into 10 to the power of minus 3 ampere. Now what you have to find out? R equals question mark. Resistance of the resistor is to be find out. Now you know the relation among V, I and R, that is V equals Ri, or R equals V by I. R equals V by I, and V is 12 volt and current is 2.5 into 10 to the power of minus 3 amps, that equals, that is 12 by 2.5. You take here 10 to the power of 3, that equals 12 into 1000 by 2.5. If you take the if you remove the decimal point, it becomes 12 into 1000, one zero more, and this 2.5 becomes 25. If you put 1 0 more in the opposite numerator, so it becomes 25. Now here you know that 25 ones are 25 fours are 100, 0 0. 25 400 the 10,000. So 12 fours are 48 and 12 into 400 is 4800 ohm. What is the resistance of the resistor? Therefore, resistance of the resistor is 4800 ohm. That is the answer for the question here. Now the ninth question. A battery of 9 volt connected in series with resistors of 0.2 ohm, 0.3 ohm, 0.4 ohm, 0.5 ohm and 12 ohm respectively. How much current would flow through the 12 ohm resistor? So we have to find the amount of current flowing through the 12 ohm resistor, and it is given that there are 1, 2, 3, 4, 5 resistors which are connected in series. In connection with series, you can have the equivalent resistance or the total resistance is equals to sum of the resistance of individual resistors. So you can have the solution here. Take R1 equals 0.2 ohm, R2 equals 0.3 ohm, R3 equals 0.4 ohm and R4 equals 0.5 ohm and R5 equals 12 ohm. Now total resistance Rs, here the connection is in series, so you take, as the series connection is there, you consider total resistance Rs equals total resistance Rs equals, what is that, 0.2 plus 0.3 plus 0.4 plus 0.5 plus 12 equals, here 2 plus 3 5, 5 plus 5 1, it becomes 10 means, and 12 plus 1 13, 13.4 you will get. What is the total resistance in series? 13.4 ohm. And current through the series circuit is, you know that I is equals to V by R, that I is equals to V by R. Here I is equals to what? 9 by 13.4, that is the current in the circuit. Otherwise write here I equals question mark, that is I in the circuit, it is I in the circuit. So you write current in circuit, because it is a total current in circuit, I equals V by R equals 9 volt by 13.4 ohm, and here you can have 90 by 134, that is current you can have, first you write V by ohm only, then 90 divided by 134, or first you try to cancel it to simplify it, that is 2 45s are 2 6 are 12 and 1 4 2 7s are, and if you divide 45 by 67, and here it is not divisible, put 0 point, take 1 0 here, and 67 6 the, okay, 67 6 the, 67 6 the is 7 6 are 42, 6 6 are 36 plus 4, 40 you will get, that is 402. Then 5 minus 2 is 8, 48 you will get, then that is 67 7s you do. Then 67 7s are 49, 7 6 are 42 plus 4, 46. So you can have, take 0 here, 7 469, then you will get 11. This much is okay. So you can have here 0.067 amps of current, that equals 0.67 ampere. Now here what you have to find out? Current through the 12 ohm resistor. Current through the 12 ohm resistor. Here there is no any change in the flow of current in each resistor, because in series connection all the resistors get same amount of current flowing through it. Therefore here what you can write, current flowing through 12 ohm resistor is equal to the total current in the circuit, that is 0.67 amps. Even though in 0.2 ohm also you will get same amount of current, in 0.3 also you will get same amount of current, in 0.4 is also you will get the same amount of current. There is no any change in the amount of current flowing through the individual resistor in the series connection. Next question, 10th question. How many 176 ohm resistors in parallel are required to carry 5 amps on a 220 voltage line? Here the resistance of an individual resistance is given, the single resistance is given, that is 176 ohm, and the parallel connection must carry 5 amperes of current on a 220 voltage line. So let us have, there are n number of resistors. So you take here resistance of, take the solution, resistance of each resistors. Resistance of each equals how much? 176 ohm. Let number of resistances equals n. Now you know that in parallel connection, here the connection is parallel, in parallel connection, that is 1 by Rp equals 1 by R1 plus 1 by R2 plus 1 by R3 plus so on plus 1 by Rn. 1 by Rn, and it is 1 by Rp equals, here R1, R2, R3, so on, Rn are 176. Each resistor is having the resistance 176. That is, you write 1 by 176 plus 1 by 176 plus 1 by 176 up to how many times you will get n factors. As there are n resistors, you will get n factors. So that equals 1 by Rp equals 1 into n time by 176. So you will get n by 176. n by 176. Therefore, here you got that 1 by Rp equals n by 176. Therefore, Rp equals, that is total resistance in parallel connection, is 176 by n. Now here, by using Ohm's law, you will get the relation R is equals to V by I. So it is 176 by n ohm. Now you write by Ohm's law, R equals what? V by I. R equals V by I. R is here, that is Rp. R is here Rp, that is 176 by n equals V is 220. Here V is given that V is 220 volt and current is 5 amps. That is I is 5 amps. So here you take that one. 176 by n equals 220 by 5. So that is, do the cross multiplication, you will get 176 into 5 equals 220 into n, 220 n. Therefore, that you can have 220 n equals 176 into 5. So n equals 176 into 5 by 220, and that you can have 5 ones are 5, 5 fours are 20, 5 fours are 20, and again you have 44 ones are 44 fours are 4 fours are 16, 1, 4 fours are 16, that you will get 44. So how many n equals here? 4 resistors. Therefore you can write that. Therefore you write 4 resistors of 176 ohm are required to carry 5 amp on a 220 volt line. 220 volt line. Now the 11th question, show how you would connect 3 resistors, each of resistance 6 ohm, so that the combination has a resistance of 9 ohm and 4 ohm. Now here, how you would connect 3 resistors? We have to show the connection to get the equivalent resistance or the total resistance of 9 ohm, and also to get the total resistance of 4 ohm. And 3 resistors are there, and each resistor is having the resistance 6 ohm. Here each resistor is having the resistance of 6 ohm. Now you write here the three resistors are R1, R2, R3. So you write the solution. So let us have R1 equals R2 equals R3. All are equals to what? 6 ohm. All are equals to 6 ohm. Now the first one is here to get total resistance 9 ohm. To get total resistance 9 ohm. That is to get total resistance of 9 ohm. So let us connect the two resistors in parallel, and next this combination can be done with the third resistance with series. So here you take, this is R1, R2 and R3. If you connect like this way, now let us verify the total resistance. Now as R1 and R2, first to take, let R1 and R2 are in parallel. So 1 by Rp equals 1 by R1 plus 1 by R2. Here R1, R2, R3 are same, they are 6 ohm. So you take 1 by R1, that is 1 by 6. 1 by R2, that is also 1 by 6. So you can have the LCM is 6. In the numerator 1 plus 1. So 1 by Rp equals 2 by 6. 2 by 6. That is 2 ones are 2 threes are. 1 by Rp equals 1 by 3. Therefore Rp equals 3 ohm you got. And you know that 3 plus 6 equals 9. So if this combination is connected with R3 in series connection. So Rp with R3 in series connection. So that becomes in series Rs is equals to Rp plus R3. Rp plus R3. So you will get Rs equals Rp is 3 ohm. 3 ohm plus R1 is 6 ohm. Totally you will get 9 ohm. So what you have to do here? To get total resistance of 9 ohm, we connect R1 and R2 in parallel combination, and this parallel combination is in series with the R3. So you take, to get 9 ohm resistance, we can connect R3 with R3 in series with R3 in series with the parallel combination of R1 and R2. parallel combination of R1 and R2. That is the solution for the A part. Next one is to get 4 ohm. To get 4 ohm. Here what you can do for this? B. To get 4 ohm. And here you can have that. Here 2 are in parallel and 1 is in series. Now let us try 2 are in series with the other parallel. So let us have, this is R1 and let us connect one more resistor R2 in series with R1, and next let us connect here that with parallel. So here this connection is made like this way. Here also that connection is needed here, cell connection, that is not shown, you must show it, plus minus. So here also you write like this way. And you know that R1 plus R2 is 6 plus 6, 12 you will get. That is 1 by 12 plus 1 by 6. Here you will get LCM is 12 and 1 plus 6 to the 12. So you will get 3 by 4, 3 by 12. That is nothing but 12 by 3, which is equals to 4. So let us solve here. So you take here what you have done, RS equals R1 plus R2, that equals 6 plus 6 equals 12 ohm you got. After that, here what you have written here, let us write that one. Let us connect. So let us connect R1 and R2. Let us connect series combination of R1 and R2 in parallel with R3. So you take first RS. RS is R1 plus R2, that you will get 6 plus 6 equals 12 ohm. Then you take the RP, then you take 1 by RP. 1 by RP equals what? 1 by RS plus 1 by R3. 1 by RS plus 1 by R3, that equals 1 by RS is 1 by 12 plus 1 by R3 is 1 by 6, that equals 1 by RP. Here it is 12. LCM is 12. Then 12 ones are 1 ones are 6 twos are 1 twos are. Then you will get 1 by RP equals 3 by 12. That is 3 ones are 3 fours are. So you got 1 by RP equals 1 by 4. Then RP equals 4 ohm. So what you have to forward? To get 4 ohm resistance, we can connect a series combination of R1 and R2 in parallel in parallel with R3. With R3 as shown in the figure. Here you note down the figure to get 4 ohm and also to get 9 ohm. Now the question number 12. Several electric bulbs designed to be used on 220 volt electric supply line are rated 10 watt. How many lamps can be connected in parallel with each other across the two wires of 220 volt line if the maximum allowable current is 5 amps? Here the voltage of the line is 220 and the electric bulbs are rated as 10 watts. They are the 10 watts bulb. Now here you take what are given here, read the solution, and given that V is given, that is 220 volts, and also current is given, that is I. So that is 5, and also power is given. Power of the electric bulb is given, that is 10 watts. Now here we have to find how many lamps, number of lamps connected in parallel. So how many lamps are connected in parallel, that we have to take. So here let number of lamps connected in parallel equals n. Now let us find the resistance of each bulb. Resistance of each bulb R equals, we have to find. So you know the relation R equals V square by P. R equals V square by P. That is V is 220. So it is 220 square by P. P is 10 watt. 10 watt is the power of each electric bulb. That equals 220 square. So you write 220 into 220, that divided by 10. So you can cancel 0 here. You know that 22 22s are 484. 484 and 0 is there. So it is 4840 ohm. 4840 ohms. Here we have taken that number of lamps connected in parallel are n. So here you take as the number of lamps are n. As n lamps are connected in parallel, then use the total resistance formula for parallel connection, that is 1 by Rp. 1 by Rp equals 1 by R1 plus 1 by R2 plus 1 by R3 so on plus 1 by Rn. As there are n bulbs are there, n lamps are there. Now you take 1 by Rp equals, that is 1 by, here you know that R you have taken 4840, that is resistance of each bulb is 4840. As they are of same resistance, here you can have R1 is also equals to 4840, R2 is also equals to 4840, so on Rn is also equals to 4840. So you will get 1 by 4840 n times. 1 by 4840, 1 by 4840 plus 1 by 4840. How many times you will get? N times. So n factors. As there are n bulbs we have taken. So there are n factors means here we have connected n bulbs in parallel. So you will get n times 1 by 4840, that is 1 into n by 4840, that equals 1 by Rp equals n by 4840. So you will get Rp equals what? 4840 divided by n you will get. That is Rp equals 4840 by n ohms here. Now here what you have to find out? We have to find out that how many lamps can be connected in parallel with each other, means here we have taken n lamps. So we have to find the value of n. Then you write R equals V by I, that is Rp equals V by I. So you write Rp is here 4840 by n equals V is 220, and you know that current is 5 amps here. Current is 5 amps. It is given current is 5 amps. So you write 5, that equals, here we have to solve for n to the cross multiplication. 4840 into 5 equals 220 n, that is 220 n equals 4840 into 5. Therefore n equals 4840 into 5 by 220. Therefore n equals, here 0 cancels, and 22 ones are, you know that 22 22s are 484, 22 22s are, and 22 5s are, you know that 2 5s are 10, 1 carrying, 2 5s are 10 plus 1 110. Here totally how many bulbs are connected? There is n bulbs, means here we have got the value of n is 110. So 110 bulbs are connected in parallel, right? Therefore 110 bulbs are, or 10 lamps are here. 10 lamps can be connected in parallel with each other across the two wires of across the two wires of 220 line.